Hi guys, I'm Mr. G and I'll be taking you through grade 10 analytical geometry, and this is of course under the CAPS curriculum. Okay, I am going to be doing this in bits and pieces. Okay, I try to keep this video as short as I can. Perhaps this one will go a little bit over 10 minutes because it's an introductory video, but the rest I'll really try to keep them under 10 minutes so that you don't find the sessions long, but rather find them stimulating, and you can actually get to move on to the next. All right, so without any further ado, I'm going to move right here into my Cartesian plane, where I have got a triangle already set up, and we are going to explore a little bit here. We start off our journey by exploring a little bit, okay, around the distance AC, okay, and of course, if you've got this already figured out, like what kind of a triangle we've got here, then that's good. This, of course, it is a right angle triangle, okay? And because it's a right angle triangle, if we are going to find this length, the length AC, okay, this length AC, we can actually then use the theorem of Pythagoras, okay? It tells us that AC squared is equal to AB squared plus BC squared. Now, the objective here is to actually express this distance AC in terms of the coordinates of A and the coordinates of C, okay? Yeah, that might be something too abstract for you at this point, but I'm going to do it slowly, step by step, so that you understand and actually follow through what I'm doing, okay? So let us recap a little bit. Point A, what are the coordinates of point A? The x value at A is this one here, which is 2. And I use a semicolon to separate my coordinates, and the y value is 8, okay? The x coordinate at B is 2, and the y coordinate is 4, right? So this one should also be fairly easy. The x coordinate is 8, and the y coordinate is 4. Now, suppose I did not know these values. What would be the general way to represent them? Okay? Instead of saying 2, if I did not know the value 2, I would write XA to say this is the x coordinate for point A. And so for Y, I should write Y subscript A also to say this is the Y coordinate at point A. So I'm going to go ahead and do the same thing for every point that I have got here, okay? So that we can see how this comes out nicely. Remember, I said the objective, we want to write the distance AC in terms of the coordinates of point A and point C, all right? Now, what do we know? Okay, we know we can use Pythagoras, right? Now, what is this distance? Let's start with distance AB. What is distance AB? Because that's what we've got here first on the equation, right? So the distance AB, if you count with me, from A to B, by the way, that's how we say it. If it's BA, then you say from B to A. Now, AB means from A to B. So the distance AB, how many blocks we've got? 1, 2, 3, 4. So you can see it's 4 units, right? And how do we get that 4? Besides counting, you can see we actually said 8 minus 4. In other words, we said here, okay, we said y at A minus y at B. That's all we said. And you can see what I'm doing here there. I'm just substituting into the formula, right? Because I told you the objective. So we are getting to the objective. Plus, what about BC? Let's count. 1, 2, 3, 4, 5, 6. Okay, 6. So how do we get that 6? How does that 6 work? Well, here it seems it is the x coordinate at B with the x coordinate at C. In other words, we said 8 minus 2. Okay? So I'm gonna go ahead here and write, well, for us to get that 6, we said 8 minus 2, but 8 is the x coordinate at C, and 2 is the x coordinate at B all squared. Now, I want you to learn something very interesting. If I say 1 minus 2, the answer is negative 1. If I say 2 minus 1, the answer is 1. But if I have 1 minus 2 and I square it, and I also say 2 minus 1 and I square it, it actually makes no difference because the answer will always be positive, meaning it will always be the same. Check, minus 1 all squared is the same as 1 squared. What is the answer? 1. Okay, that is the power of squaring things. Actually, if you square a number or a difference or a sum, you're saying you want it to be forever positive. That's what you're doing, all right? So I'm saying that, okay, so that you can allow me to do something or you can see why I'm going to do what I'm about to do. Let's check this out. Quick one. Let's see. We have YA, that's fine because that point is A. We have YB, but we don't have to we don't want YB here. Why? Because I said the objective is to see if we can express the distance AC in terms of the coordinates of A and C only, okay? So anywhere we see a B, that's something that we really need to deal with, okay? So let's come to our triangle and we will notice something incredible here. If you look at the y coordinate for B, what is the y coordinate for B? It is actually 4. Do you see that? But interestingly, this is the same y coordinate for C. And so we can see something here that actually the y coordinate at B is equal to the y coordinate at C. This is one and the same thing. Okay? You will also realize something, that the x coordinate at B is exactly the same as the x coordinate at A. And so another important observation here is that x at B is actually equal or is the same value as x at A. We're looking at the same thing actually. When you look at x at B, you are looking at x at A. When you're looking at y at B, you are also looking at y at C. That's one incredible thing to notice, right? So we're going to use that fact in our formula here. So I'm going to say now YA minus what is YB? We just established it is actually y at C all squared plus, we're going to leave this one here because it's part of what we want. And then what is the another way to write x at B is this to say x at A. And I have that all squared. Guess what, guys? We have achieved our goal. We have expressed the distance AC squared using the theorem of Pythagoras in terms of the coordinates of A and the coordinates of C. And so this, the interesting thing is that it does not only apply to a situation like this, it is not only an issue of a right angle triangle. As a matter of fact, if I were to plot 2 points here, if let me call this point P and another point here Q. Now, what are the coordinates of P? We can see it is 9 and 7, and the coordinates of Q is what? 14 and 5. If I want QP, the distance QP, I can just use what I have there and say QP squared and say actually this should give me the y at, it should be the y at Q minus the y at P all squared, okay, plus, right, x at Q minus x at P all squared. And if I want, of course, that is the square. Now, if I want the actual distance, I must take square root. And then, so that means this formula in general is like this, okay? Plus x Q minus xb all squared. And I'm not going to put a plus minus here because distance should always be what? Positive. All right. So let's wrap up. In general, we have just established that if you want the distance between any 2 points, point AC, okay, I can just write it as the square root of what? What is in my bracket? I can say here XA minus XC all squared plus YA minus YC all squared. One thing that I want you guys to note, which I think is quite important, is consistency in how you look at your points, okay? So if you're gonna start with A and say XA, please do the same thing for YA. If you wanna say XC, do the same thing there, finish with YC, okay? At this point, it is really immaterial because of the square. But I want you to practice this because when we get to the point where we study the gradient, it will actually matter. So as a thumb rule, be mindful of this. Of course, this was still okay if you said xc minus xa, x at a, all squared, plus y at c minus y at a, all squared, or you can say quantity squared. Okay, all that. That will still be cool. No problem. I just want you to be consistent. If you start with the coordinate of C in one part, also start with the coordinate of C in another part, okay? Don't get that mixed up. It is good. Practice, you will see why I say that, all right? So I'm gonna end it here, guys, for this introduction. Might have been a long one. As I said, my apologies. It is because we are just starting the next. They will be quite brief and straightforward. So in the next video, we're gonna take few examples rather on how to use this distance formula, some application. Okay, we're gonna use it to prove stuff. So until then, I'll catch you guys later.